Welcome back, and today we're talking about equations with special solutions. And I'll give you a couple examples of each of them. There are two. So if we have an equation like 2 plus m equals m minus 6, well, we solve this just like normal. We move our variable to the other side, or combine our variables, our like terms, and you're going to notice, well, there's none smaller than the other. Normally, we always move the smaller one. Well, we'll just move what we can, minus m. If I minus m from both sides, though, both my variables cancel, and we are left with 2 equals negative 6. So this is as far as we can go, and we look at this. Does 2 equal negative 6? Nope. That's false. Because that's false, we say this equation has no solution. Okay, guys? And usually, you're going to see no solutions when variables are eliminated and you're left with a false statement. And again, 2 equals negative 6 is an example of a false statement. Let me show you one more. It'll be kind of a bigger problem. Let's go 13 minus 3m equals 8 minus 3 parenthesis negative 1 plus. So we solve this guy just like we normally would. We are going to take this negative 3 and distribute it first, because that is a distribution on that side. We want to take care of that. So we have 13 minus 3m equals 8. Negative 3 times negative 1 is positive 3. Minus 3m. Yep, because we did the negative 3 times m. And of course, we combine our like terms next. Be like, okay, well, there's 11 minus 3m equals 13 minus 3m. We want to get our m's on the same side. And again, we notice, ooh, these guys are the same. Okay, so what happens? I plus 3m both sides. They both cancel. And we have 13 equals 11. Again, that's another false one. So you write no solution. These things don't happen all the time with algebra, but they do happen occasionally. And when they do, you don't need to get flustered. Just, oh, I know how to do that. The variables have canceled. I'm left with a false statement, so there's no solution. Now, there's one more thing, though. One way that you're going to get something a little different. I'm going to show you. So what if I go 7a minus a equals 6a? This guy, I'm going to put a 1 before my a, right? There's an invisible 1. We're going to combine our like terms. 7 minus 1 is 6. So I got 6a equals 6a. All right, well, let's just keep solving. I'm going to minus 6a both sides if I want. My 6a's both cancel. And I have 0 equals 0. Remember, when something cancels, there's really a 0 on that side. This one is slightly different because this is true, isn't it? Because we get to a true statement at the end, we write infinite solutions. Or you might have all real numbers. They're really saying the same thing. So you can just ask your teacher which one you should write. But the idea is anything that you substitute into that equation will work. Okay. Let's do another. I'll give you one more. I can go negative 40 minus 8x equals negative 8 times x plus 5. We're going to distribute just like we normally would. I have negative 40 minus 8x equals, distribute this guy, negative 8x minus 40. I'm going to move my variables to the same side, plus 8x both sides. They both cancel, so we go negative 40 equals negative 40, and we're done. That is a true statement. So infinite solutions are all real numbers, whatever you want to put. Okay. And why do we have infinite solutions here? How do we get to that? When variables are eliminated and we have a true statement. That's how we know if something has infinite solutions. All right. So you'll see again those problems rarely, I'd say, but I want you to know how to work with them when you do. Again, don't get confused by them. Just is this, my variables have both canceled. Is the ending statement true or false? If it's true, you've got infinite solutions, and if it's false, you've got what we did here, which is no solution. Thanks for watching. Have a good day.